Okay, so today, sorry, listen to me. Okay, fine, I'll just take it. Okay, fine. See, last class, what we have been discussing was we have been discussing about context-free grammar, and then let me just go up and just check for it. Okay, what we have seen was context-free grammar we have seen, and then reduction of context-free grammar, and then from conversion of reduced context-free grammar to Chomsky normal form, and then from Chomsky normal form to Greivek normal form. I have already mentioned that why we are machine which is going to accept. So this part we have already seen in last week. So today I'm going to start discussing about the machine which is known as push-down automata. And regarding this machine, right, I'll just tell a few points. Uh, previously we would talk about finite automata. The language accepted by finite automata is known as regular language. And next machine which we are going to discuss today is known as push-down automata. And the language accepted by push-down automata is known as CFL, which is context-free language. Okay. Now, from the given grammar, we can easily derive the language. So the grammar being the backbone of this particular language is known as context-free grammar, which we have already studied. So today I'm going to start about this push-down automata. Okay, let me just draw the block diagram here. This is the input tape. This is the finite control. This is the finite control. This is the input tape. And then the disadvantage of push-down automata compared to finite automata is it has a memory. And what kind of memory is being utilized in here is stack as a memory. Okay, and then when we talk about stack, right, we already knew that this is last in, first out policy it's supporting. And then regarding stack, right, another attribute of this stack is top pointer. Top pointer. There will be always a pointer which will always pointing the top of the stack. Okay, that's the attributes of this one. This is the block diagram of push-down automata. And then let me define this machine mathematically. So let me represent push-down automata as MPDA. Let me define this as Q. Okay, this is set of states. This is set of states. This is set of input symbols. Set of input symbol, and then this one is set of push-down symbol. Don't worry, I'll be taking one example. With that example, we'll be explaining what do we mean by this push-down symbols and all. Okay. For the time being, I'm just informing you what are these terms signifies in this mathematical definition of a push-down automata. And then this is transition function. This is transition function. Transition function. This is initial state. Initial state. And then this is set of final states. Final states. Okay. So this is the block diagram of a push-down automata. And then this is the mathematical definition of a push-down automata. Now, Simply, I'll just take one example. So better that way we'll explain. And then one more thing. In the case of finite automata, right? In the case of finite automata, when you try to check the acceptability of a given language, then how we used to check is that, then suppose this is the initial state Q naught, and then once after processing that particular given string or whatever, if it reads the and they are concluding well is being accepted, okay, finite automata. But in the case of push-down automata, right, there are two kinds of acceptance of a given language. So let me just describe that one. Acceptance of PDA. Okay, so this one, right? First type is the given language could be accepted by the push-down automata by reaching the final state. Okay, by reaching the final state. And the second type is it will accept the given language by emptying the stick. Okay, I'm telling you again, don't worry. I'll just take one example, and then with that example, we'll be explaining that one. Okay. So now I have just written what are the things to be informed to you guys. So let me just take one example. With that example, I'll be describing each and every step of a given push-down automata. So let me just begin with that one. So let me just write an example. Design a PDA which accepts the language L W belongs to A comma B is where W has the equal number of A's and B. W has equal number of A's and B's. Okay. Now we are going to design a machine which is going to accept this language. And then let me just write what kind of language to be accepted by this machine. See here, A, B will be accepted. As per this language description, it is a combination of A, B, where the number of A and number of B will be equal. Okay. Now this A, B will be accepted because number of A is 2, number of B is 2. And then A, B, E will be accepted because number of A's and B's are equivalent to each other. And then B, B will be accepted. B, A will be accepted. And then A, B, A will be accepted. B, A, B will be accepted. Number of A's is equivalent to number of B. So like this, the language described here is nothing but it's a combination of A and B where the number of A's is equivalent to number of B. Okay. Now, I don't know what are the, how many numbers of states will be required for this. And then one more thing, this is clean closure is enclosed here. So definitely this one has to be accepted. I mean, empty string has to be accepted for this one also. So now I don't know about the Q. So definitely we'll be having Q naught, which is initial state. And then after that, I don't know, let me just write a Q final state like this, QF. And then the input symbol will be A, comma, B, comma, epsilon. And then this push down symbol, right? It's for the time being, let me use the same as it is, and then let me introduce a new symbol, jet. You might be a bit confused, so let it be as it is. I'll be explaining it in a very slow manner, so don't worry. So I've already introduced QF as the final state, so let me just write QF like this. Okay, so this one, how many states I'm going to have, I don't know. So still, I'm just writing. Now, how to define machine completely means it depends on this transaction. Finite material, we have all functions and all. So in the case of push down automaton, it's a little different. In the case of push down automaton, it's a little, yes. Yeah, what happened?
Your voice is breaking too much, ma'am. I think network problems.
Yeah, network problem, but forcefully I just check it. I just started the class. Wait, let me just check. How long it has been broken, I mean? Is it audible? See, I'll just...
Yes, ma'am. No, it's audible.
No. Till this part, whatever I have explained, is it fine or like...
Yes, ma'am. It's fine, but in between, after a few minutes, it breaks for a while, 30 seconds or 40 seconds.
The network issue I'm facing. Okay, I'll end here. Tomorrow I'll just start from 11th. Okay. From my I'm using my data from my mobile. This Google Meet, right? I have initiated from my mobile. Okay. I'm facing some problem in my handset. Okay, I'll end it here.
Okay.